Welcome. Today, let us take few problems on derivative and mean value theorem. The first problem is in minus pi by 2 less than x less than pi by 2 ddx of tan inverse root over of not root over, tan inverse cos x by 1 plus sin x is options 0 to half and minus half. So it is also very simple problem. One function of x is there and we have to find its simple derivative, and the range of function is given within minus pi by 2 to plus pi by 2. Now we know that cos of cos x by 1 plus sin x, it is equal to cos square x by 2 minus sin square x by 2. Cos x is cos 2x, formula of cos 2x is cos square x minus sin square x divided by 1 sin square x by 2 plus cos square x by 2 plus 2 sin x by 2 cos x by 2. So that it is equal to cos x by 2, cos square x by 2 minus sin square x by 2 by cos x by 2 plus sin x by 2 whole square. So that one factor cos x by 2 plus sin x by 2 cancels and this become cos x by 2 minus sin x by 2 divided by cos x by 2 minus the plus sin x by 2. Now dividing by cos x by 2, it become 1 minus tan x by 2 by 1 plus tan x by 2. It is equal to tan pi by 4 minus tan x by 2 by 1 plus 1 means tan pi by 4 into tan x by 2. So that it is equal to tan of pi by 4 minus x by 2. Now the given function is this, we have to differentiate that. Therefore ddx of tan inverse cos x by 1 plus sin x is equal to ddx of tan inverse of that means tan inverse tan of that. So it become pi by 4 minus x by 2. Now its derivative 0 and its derivative is minus half. So minus half answer. Fourth option correct. Next. The next problem is if fx is equal to tan inverse x and f dashed x plus f double dashed x is equal to 0, then x is how much? Options: -1, 1, 0, and 2. That problem was given in WBJEE in 2013, and previous problem, just now what I did, it was given in West Bengal Joint Entrance Examination in the year 2012. I forgotten to mention it. So now this is also a very simple problem. Fx is that, so f dash x 1 upon 1 plus x square. F double dash x, it is equal to derivative of that, so minus 1 by 1 plus x square whole square into 2x. It is this to the power minus 1, its derivative is minus 1 into this to the power minus 2, and derivative of this is 2x. So as per condition, 1 upon 1 plus x square minus 2x by 1 plus x square whole square is equal to 0. Multiplying this by that whole thing by 1 plus x square whole square, so that 1 plus x square whole, not whole square, 1 plus x square minus 2x divided by 1 plus x square, that is equal to 0, so that this becomes 0. So that 1 plus x square minus 2x is equal to 0, that is 1 minus x whole square is equal to 0, therefore x is equal to 1. So second option is correct. Now the next problem is if y is equal to tan inverse root over 1 minus sin x by 1 plus cos x, not that 1 plus sin x, then at x is equal to pi by 6 dy dx is options: minus half, 1, minus 1, and 2. And that problem was given in (2009). It is inverse tan inverse function, and within root over it is 1 minus sin x by 1 plus sin x. We can put it to a whole square form, this and that together, But one thing we have to keep in mind, when we remove square root, we have to keep in mind that the whole thing within that must be positive. Now, near x is equal to pi by 6. So just 1 minute. This thing is 1 minus sine x by 1 plus sine x is equal to sine square x by 2 whole square plus cos square x by 2 whole square, that is 1, minus 2 sine x by 2 cos x by 2 by, same case, 1 means sine square x by 2 plus cos square x by 2 plus 2 sine x by 2 cos x by 2. Now, denominator, no problem, plus sign is there. So it is sin x by 2 plus cos x by 2 whole square. But numerator, as because the product term is negative, it may be sin x by 2 minus cos x by 2 whole square, or it may be cos x by 2 minus sin x by 2 whole square. Now, which one we can accept? Mind that x is given at the point pi by 6. So near pi by 6, this is positive and this is negative. So we have to accept that. So that it is equal to cos x by 2 minus sin x by 2 whole square by cos x by 2 plus sin x by 2 whole square. Now the given function is y is equal to tan inverse root over of that means cos x by 2 minus sin x by 2 by cos x by 2 plus sin x by 2. So that dividing by cos x by 2, it is tan inverse 1 minus tan x by 2 by 1 plus tan x by 2. Just now we did one problem and it is equal to taking this as tan pi by 4. 1 mean there is 1 plus 1 into that, it is also tan pi by 4, so that it can be written as tan inverse tan pi by 4 minus tan x by 2 by 1 plus tan x by 2. That is, it is equal to tan inverse tan of pi by 4 minus x by 2. So that it is equal to pi by 4 minus x by 2. This is our y is equal to this is equal to that. So it is y is simply simplified value of y is pi by 4. This is pi by 4 minus x by 2. So derivative of that at x pi by 6, dy dx is equal to 0 minus half. So that answer is minus half. So first option is correct. Though we have not, there is, after derivative it is free of x, but mind that we accept either this formula or sin x by 2 minus cos x by 2 whole square. Which formula to be taken, it should be determined from that fact. Next, বেড়ে গেছে। তো next problem is, if x is equal to e to the power t sin t and y is equal to e to the power t cos t, then at x is equal to pi d2y dx2. To calculate double derivative of y with respect to x at the point x is equal to pi. So, as before, in my last class, we have taken a problem like that. It is a parametric function, so we have to calculate dx dt, which is equal to derivative of e to the power t is e to the power t into second factor plus first factor intact derivative of the second factor. Similarly, dy dt, it is equal to e to the power t into cos t intact plus e to the power t into derivative of the second, which is minus sin t. That's why it is minus sin t. So that dy dx is equal to dy dt by dx dt, which is equal to this by that. E to the power t will be cancelled all along, so that we get cos t minus sin t by cos t plus sin t. So dy dx, it is a function of t only. Now, for second order derivative d2y dx2 is equal to d dx of, it can be simplified. This can be written as 1 minus tan t by 1 plus tan t. It is equal to tan of pi by 4 minus t minus tan t by 1 plus tan t. Yes. So d2y dx2 is equal to d dx of dy dx, that is pi by, it is tan of pi by 4 minus t. But as because it is a function of t, not possible to differentiate with x. So this can be written as d dt of tan of pi by 4 minus t dt, but it was d dx. Now adjust. So that it is, now it can be differentiated. Tan function derivative is sec square pi by 4 minus t sec square pi by 4 minus t into minus 1, because derivative of this is minus 1, into dt dx. dt dx is 1 by dx dt, so that it is equal to e to the power t into sin t plus cos t. Therefore, at x is equal to pi, x is equal to pi, just 1 minute. It is the 2y dx2. Oh, the problem is to find that x is equal to pi by 4. X is equal to pi. So that it is x plus y. This is x plus y. But you see, the at x is equal to pi. So t, what is t? Acha, okay. I do it next day. Now our next problem. If fx is equal to e to the power x, gx is equal to sine inverse x, and hx is equal to f of gx, then h dash x by hx, how much? Options: e to the power sine inverse x, 1 by root over 1 minus x square, sine inverse x, and 1 upon 1 minus x square. Okay, now let us see what is hx. Hx, originally it is f of gx. F function means fx is equal to e to the power x, fx e to the power x. Therefore, it is equal to e to the power, instead of x, it would be gx. Fx is e to the power x, so it is f means e to the power gx. It is equal to e to the power sine inverse x. That's because answer is in terms of h dash x by hx. Let us take log on both sides. In that case, log hx, of course base e, is equal to sine inverse x into log e. Log e means 1. Now differentiating both sides with respect to x, it is 1 upon hx into derivative of hx. 1 upon hx and derivative of it is equal to 1 by root over 1 minus x square. I think this is our answer. H dash x by hx, and it is that. So option B is correct. Next. Let fx is equal to 2 plus x minus 1 to the power 2 by 3. Then which of the following is oblique are correct? Options: F0 is equal to F2. F is differentiable in 0, 2. F is continuous in 0, 2. Rolle's theorem is applicable in 0, 2. So, in this case, one function is given and some conditions are there, f0 is equal to f2 and so on. Which one or more than one answer may be correct. So we have to test one by one. So f0 how much? f0 is 2 plus minus 1 to the power 2 by 3. So minus 1 to the power 2 by 3 is 1. So that 2 plus 1 is equal to 3. F2 is equal to 2 plus 1 to the power 2 by 3 means again 1, 3. So F0 is equal to F2. That is correct, number 1. The next we have to see whether it is differentiable in 0, 2 or not. Derivative of that f dash x is equal to 0, 2 by 3 into 1 by x minus 1 to the power 1 by 3. 2 by 3 into this to the power, this minus 1. 2 by 3 minus 1 is minus 1 by 3, that's why in denominator. Now, f dash, it is derivable or not within the closed interval 0, 2. The derived function has some denominator and that denominator vanishes at x is equal to 1. So it is not derivable in the range 0 to 2. So this is not possible. If this is not possible, Rolle's theorem also not possible. Now let us see whether this one is continuous or not. The function is algebraic function having no denominator and within finite range it is continuous everywhere. So in 0, 2 it is continuous. So this is also correct. So option 1 and option 3 are correct. Oh, that problem was given in the year. This problem is given in the year 9. Now next problem. Find dn dx to the power n of log x base e. To find nth derivative of that. So options: minus 1 to the power n minus 1 factorial by x to the power n. Second option, factorial n by x to the power n plus 1. Third option, factorial n by x to the power n. Fourth option, n plus 1 factorial by x to the power n plus 1. That problem was given in the year West Bengal Joint Entrance in 2007. Actually, we have to differentiate this function successively, means one after another n times. So this can be written as, this is dx to the power n minus 1 into ddx of log x. It is equal to dx to the power n minus 1 into 1 by x. So it is differentiated once. Next time by same approach, this is dx to the power n minus 2. So we have to differentiate this minus 1 into x to the power minus 2. Continuing this process, dx to the power n minus 3 into minus 1 into minus 2 into x to the power minus 3. This is differentiated first time, second time, this is third time. In third time, it is equal to that. So continuing this process, after differentiating n times, this become minus 1 into minus 2 into minus 3 up to minus n minus 1. X to the power minus n. Continuing this process, we get that result. It is equal to, there are n minus 1, there are factors. So minus 1 to the power n into 1 into 2 into 3 up to n minus 1 into x to the power minus n. So that answer is, it is n minus 1. So answer is minus 1 to the power n minus 1 factorial of n minus 1 by x to the power n. Actually, this is that option is this, and this is the answer. Okay. Next day, we will take few more problems on that. Today, thank you.